we now have the general formula for an object that's under the influence of gravity. And I guess I've skipped the y right there on the word gravity. The g is the acceleration to gravity, and pretty much you need to memorize that if we're dealing with feet per second squared, it's going to be 32 feet per second squared. But if we're in metric dealing with meters, we're going to have 9.8 meters per second squared. Those are values that you need to know on your own. Now, v subscript 0, that's the velocity at time 0, also known as the initial velocity. And s, we don't use d for distance, we use s for distance. The initial vertical distance, or at time 0, is s sub 0, and so that's the initial position. That's needed for this next problem. We want to derive the formula, and I'm going to start with, again, what we have up above. S sub t is equal to -1/2 gt squared plus v sub 0 t plus s sub 0. It tells us the initial velocity is 16, so I can substitute 16 right there, and it's feet per second squared. That tells me the g value is going to be 32, and let me see, he's leaving the ground, so his initial height here will be a plus 0. So we have s of t is equal to -1/2 times 32 times t squared plus 16t plus 0. And if we simplify that, we will have s of t is equal to -16t squared plus 16t. That's the general model. Now we want to find the times after leaving the ground when the player will be at a height of more than 3 feet in the air. So since our function we've just solved for deals with the height, we're going to take this -16t squared plus 16t and set it to be greater than 3 feet in height. And so we have a quadratic inequality, and I would prefer to have a 0 on the right hand side, so I will subtract 3 on each side, and that gives me -16t squared plus 16t minus 3 is greater than 0. And since we don't like that negative leading coefficient, I will divide through by -1, and that will give us 16t squared minus 16t plus 3 is less than 0. Because I divided each side by a negative, I need to change the direction of the inequality. Now we're going to factor the left side, and that will give us 4t minus 1 times 4t minus 3 is less than 0. And so on a number line, our two critical values are 1/4 and 3/4, and we need to try a test value off to the left of 1/4, and I'm going to suggest 0. Let's stick it into this line here. 16t squared, that's 16 times 0, minus 0, plus 3. 3 less than 0 doesn't make sense. We want this to be less than 0. This is actually above 0 when you stick 0 in, because you get a positive 3. It turns out when you substitute a value in the middle, like 1/2 in, you get a negative, and over on the right you get a positive. And we are interested in where this is less than 0. When will they be at a height of more than 3 feet in the air? The answer is in the interval from 1/4 to 3/4 seconds after jumping.